All right, I went to Texas A&M, so I have to do this. Howdy. Oh my God, okay. I'm still not used to not living in Texas anymore, so I get that whenever I can. So yeah, I live in Florida now, I moved, but I will always be home in Texas. So anyways, I'm here today to talk to y'all about how we are working to industrialize space. And Maiden Space is, I guess, a unicorn in some respects in that we are, a small growing business who runs entirely off of revenue. So I'm not the guy to talk to about how to go get VC money, but I am the guy to talk to about how to put together an amazing technical team and an amazing value proposition and go build something new with that. And that's what we're doing every day at Maiden Space. But I also think it's important to recognize that we are here today and we exist as a company today because of decades of work and lessons learned that came before us. And that's all building towards that grand vision of the future that Tori talked about this morning. And so I'm gonna kind of share with y'all our view of how we got here and where we're going next. So when we talk about space industrialization, what do we mean? In this particular context, we say that means that we are moving the means of production off-world, whether that is building things in space to be used in space, or that is building things in space to be brought back down and used terrestrially. We're taking advantage of the unique environment, whether that's microgravity, like Erica talked about, or the actual space environment itself to do things that we can't do on the ground. But this is not a new idea. In 1961, Ralph J. Cordner, the president and CEO of General Electric, wrote an article for his friend who happened to be one of the co-founders of TRW about what he called competitive enterprise in space. And when my mom was as old as my son is today, he laid out all the principles for why American entrepreneurship is the example for how we will move out into space and move things beyond being entirely government-led enterprises. In his treatise on the peaceful uses of space, he said that we go to explore, we go to develop, and we go to mature. So in his mind, what we did was use government-led research and development and exploration to push back the boundaries. You then develop useful cases within that new sphere of influence, and then as it matures, then you can have fully self-sustaining competitive enterprise take over. And he's written at length about what's the right way to strike that balance, what are the pitfalls, all very prescient. And so what happened? Why are we still to a large extent in the explore and very early development stages? Well, the space race happened. And if you've studied national security policy, you know that Clausewitz said that war is the continuation of politics by other means. That's exactly what the moonshot was for us. It was a geopolitical battle with the Soviet Union that could be won without having to shoot anybody. And once it accomplished its purpose of demonstrating American technological superiority, the political and financial support dropped from the 4% of the federal budget that NASA got at the height of the Apollo program to the roughly 0.5% that it stayed at in the intervening decades. So what are the right lessons to take from that experience, and how do we build a more sustainable enterprise, knowing that NASA's purchasing power has remained flat for the past 30 years and is likely to remain flat going into the future? Well, Gerard O'Neill in the 1970s started looking ahead to what that meant. And he wrote a book called The High Frontier. And his vision, much like we hear people like Jeff Bezos talking about today, is millions of people living and working in space, building cities where people can feel as comfortable as they do in a city park here on Earth today, but their jobs are building space-based solar power plants or building deep space transit vehicles to continue to explore and push out further. There was only one problem with O'Neill's model. It was that it was based on the initial estimates of how cheap and how fast space shuttle was going to fly. As we all know, that's not what happened. The space shuttle was an experimental system, a wonderful, lovely, capable system that I grew up watching fly and that I was fortunate enough to get to see launch and land on multiple occasions, both as an enthusiast and as a young engineer. But it was not as cheap as we initially thought it would be, and it didn't get to fly as often as often as we thought it would. But what we did learn from the SKYLAB, shuttle, and early station era was the fundamental science about how microgravity is different and why that's important. And that set the stage for all the amazing things that we're able to do today, both on the space station and in commercial space with small satellites and other revolutionary technologies. So, again, like I said, this is not the first time people have tried to commercialize low Earth orbit. There were commercial launch ventures in the 1980s. There was a company called Space Industries Incorporated that had deals with 3M and Westinghouse to do commercial R&D in space. But what was different then from the way things are now is that we actually have the policy frameworks and the support from key stakeholders on Capitol Hill and in NASA to actually use the resources that the taxpayers already invested in to create new businesses and move from a science-driven model towards an entrepreneurial model. And really the key part of that is the existence of the ISS National Laboratory, which is managed by CASIS, the Center for the Advancement of Science in Space. For the first time in really the history of our industry, we're treating the space station just like we treat Sandia or Argonne or Oak Ridge National Laboratory, in that we're taking these national assets that have been used to accomplish key scientific missions for the government and making those resources accessible for terrestrial use. So if I put in a proposal to CASIS to put a commercial payload on the space station, as long as I cover my own costs, they will give us the ride to and from station. They will give us access to whatever crew time and consumables resources we need on station, because Congress passed a law in 2010 that said that NASA is obligated to share at least 50% of all of its available resources for research for non-NASA use. And that means that anybody that has a great idea for what we can do in microgravity or what we can do in the space environment to build new businesses and to build new research opportunities can do that. And I've been fortunate enough that, before I came to Made in Space, I spent 7 years first at JSC and then at CASIS helping create those opportunities and see how we could use space station as an industrial tool. So, taking advantage of that change in capabilities and that change in policy, we very strongly believe that there are really three main reasons why you want to industrialize space. You want to build to explore. So we are fast approaching the limits of what we can do with existing technology, where you have to fit everything all origami style inside of a launch shroud. James Webb is really about as far as you can push that technology. But to do the next generation of deep space science missions for like direct imaging of exoplanets, you need much larger apertures and much more sensitive instruments than what we have today. And we believe that that requires in-space manufacturing and assembly. You can also build to extract. So that's what we talked about before, about building solar power stations so that you can get endless energy when the sun never sets. Our Z-band fiber manufacturing project that I'll talk a little bit more in a minute. And then the other reason is that you build to edify. And so when I say that, we're talking about elevating the human condition. As we go into space, we are learning how to take better care of this planet. We are learning why the environment's changed on other worlds, and it's helping us be better stewards of our own home. And so when you take all of that in combination, I think you can see a vision for how we can use the resources and information and abundance of space to make life better for everybody here on Earth. So you can build new space systems. We're working with companies like Northrop Grumman, Boeing, and Lockheed on developing in-space manufacturing to build much larger baseline structures than is currently possible. With our prototype machine in California, we just won the Guinness World Record for the largest continuously manufactured 3D structure. We built a 127-foot long beam in our laboratory in California. We had to hang it from the ceiling because NASA wouldn't let us knock out a wall to take it out of the building. We're also working on new space products. So for the very first time in December, we flew a commercial optical fiber manufacturing machine to the space station. We built on research that NASA and the Air Force did on parabolic aircraft in the 1990s and 2000s, but partnered with North America's leading terrestrial producer of this material to show that you can make it between 10 and 100 times better than silica fiber in space. And with that tremendous performance improvement and much wider transmission window than the existing technology, this is a material that is valuable enough in today's limited markets that it's actually more expensive than the cost of launch. So that's something we can actually build a sustainable business model on once we've perfected the process, taking advantage of the national laboratory to learn what works and what doesn't work. And we think that is the model for building new businesses in space. We're also working with our partners at the large space agencies like NASA, DLR, and ESA on advancing in-space manufacturing for new mission capabilities, whether that's refining resources on the surface. So for example, we've done an internal research project on taking atmospheric carbon dioxide, local water, and local soil to make manufacturing materials. So you don't have to carry everything you need to build a base camp. We can build the bulk structures using local materials and robotic assembly and then outfit the habitats when the crew members get there. We also did a NIAC study on sending a seed craft to an asteroid that would then use local materials to build large mechanical structures so that you essentially have like an asteroid propelled by integrated, automated, synchronous trebuchet. So it's like a poor man's mass driver. As well as working with NASA on projects for actually refining lunar resources into feedstock for metal additive manufacturing. So we see that really over the next 10 to 20 years, we think there's going to be a tremendous expansion of capability due to in-space manufacturing. And it stretches all the way from low Earth orbit out to deep space, whether that is augmenting CubeSats with much larger antennas than they could carry with traditional deployable structures, to a project that we're doing with DARPA right now in partnership with Moog CSA to take an ESPA ring and turn it into a phased array and antenna system for small satellites, to our partnership with Northrop Grumman to build large structures in space for high-power solar arrays and deep space instruments. The first big wave in change was getting access to space in the first place. We're now seeing a second wave of change with companies like SpaceX, Blue Origin, and ULA, as well as the small launch providers and small satellite developers taking advantage of modern industrial practices here on the ground to reduce the cost and access to launch. The next step function is doing in-space manufacturing so that you can take advantage of the native environment and build things that you could never build on the ground, but you still need to accomplish those high-value, high-quality missions that we need to continue pushing back the frontier and realize Cordner's vision from 50 years ago. and actually make space accessible for everyone. But there's a necessity driving this. If you are familiar with Joseph Tainter, he wrote the seminal text on the collapse of complex civilizations. And his basic premise is that societies collapse when they are unable to use their available resources to solve complex problems. Whether it was Rome or Easter Island, that was the common thread that ran through all of them. Or if you're a fan of the British rock band Muse, like me, and you listen to their album, The Second Law, they say that a society that's set on endless growth is unsustainable. Well, that's only true if we treat Earth like a closed system. But we know Earth isn't a closed system because we get constant sunlight from the sun. We know what resources are out there in the solar system. So if we want to live in a world of radical abundance where every human being is free to pursue their own bliss, and we one day build starships, that's where we have to go. That's what we have to do. And I couldn't be happier to be part of a company that's making that vision come real. Thank you.